Good morning, my grade 7 wonderful students who do all the work that I asked them to and are slowly getting there, so well done. So, this is the second task that you've been asked to do this week. This is circumference of a circle, and the live lesson we did the other day was to do with the area of the circle. So just to give you a little bit of a recap, area, if you think about it like a pizza, area is all the space, or should we say the toppings on top of the pizza. So that is the area. But today we are doing the circumference, and the circumference is not the toppings, but the crust on the outside of your pizza. So how big, what is the distance around the outside of your pizza? So if I was to take a pair of scissors and cut that, or even a piece of string, and I was to lie it flat, that there is the circumference of your circle, because you could fold that back up and you could make a circle of it. So the circumference is the distance around your circle, which in math we can also say the perimeter. So circumference is the same as the perimeter, only in circles we call it the circumference. So if you remember back to our little song, pi r squared sounds like area to me. If you need a circumference, you can use pi d. So circumference is equal to pi times diameter, which I gave you on the last live lesson as well. Or you can say it's pi times 2 times the radius. So you've actually got two formulas you can use. You can use pi times the diameter, and you can use pi times 2 times r. Why? Because, as we said in the last video, that rd is equal to 2 times r. Or we can say that r is equal to d divided by 2. So if you've got a diameter, you can divide it by 2 to get the radius. And if you've got a radius, you can times it by 2 to get the diameter. That's how they link. And if you forgot about what a radius is from the center to the edge. So any line from the center to the edge. So that can be a radius, that can be a radius, that can be a radius. Anywhere from the center to the edge. Now a diameter is through the center, but it's from one end of the circle to the other end. So a diameter is 2 radiuses. So look, one radius plus another radius. So diameter is 2 radiuses combined. So hopefully you're finally understanding that. So I'm not going to do all of these. That is your job for this week. I'm going to do a couple. I'm going to do one where I have a diameter and one where I have a radius. And then you can see at the end there's a little trick one where it gives you the circumference and you've got to work out the diameter. So actually you've got to rearrange the equation. But I'm just going to make that easier for you and give you the formula so that you don't need to mess about with your rearranging. But we'll do that in a bit. So if you look at the first one, you've been given a diameter which is 2. So here is the diameter, and it's asking me to find the circumference correct to 1 decimal place. So I look at my formula. Which one has a diameter? Well, it's the first one. So circumference is equal to pi d. So C is equal to pi d. Now, you might be thinking a pi next to a d, but there's no symbol there. Well, you should know that when a pi is just a number and it's next to a letter, so if you think back to algebra, what that means is pi multiply by diameter. So that's what you're going to do in your calculator. Now, I showed you all that there's a pi button on your calculator, or just to remind you, if you can't find your pi button, you can use pi is equal to 3.14. So, pi times, and d is 2 in this case. So if you pop that into your calculator, it's going to be 6.28 to 2 decimal places. However, it wants it to 1 decimal place, so that's going to be 6.3. Yeah, very easy. So you just use your formula and you substitute in whether it's a diameter or it's a radius. So I'm going to look at number 4 now. This one has a radius of 9.7. You see the difference? It's only a line from the center to the edge, not a full line. And it's asking me for the circumference. So this was question 1. This is 4. So again, I write my formula, but looking at the formula now, I'm going to use this one because it involves radius. So C is equal to pi times 2 times r. That's what it means when you've got pi 2r. All timesing. So C is equal to, and r this time is 9.7. So pi times 2 times 9.7. And that's a lot larger than the last circle. So although it's the same size in the picture, if I was to draw it realistically, it would be much bigger. And that gives me 60.9 to 1 decimal place. Okay, boys and girls, that I think finding the circumference is a lot easier than finding the area. It's a much simpler formula. You just have to notice whether you've got a diameter or whether you've got a circle, a radius in your circle, and you have to use the appropriate formula. Right, let's look at one that's a little bit different, and that is this one, where it doesn't give me the diameter. There is no diameter, but we've got to find it. So it tells us that the circumference is 70, and we've got to calculate what the diameter actually is. So how are we going to do that? So if I just scroll down and write number 5, what you got to know here is a new formula. If I rearrange this, then basically using a little bit of algebra, well, if C is equal to pi d, which is here, then if I rearrange that, d is equal to C divided by pi. So you can rearrange the equation in order to find the diameter. So C equals pi times diameter, so if I rearrange it, I do the opposite, take the pi over, which is multiply, and it becomes divide by pi. So D is equal to, and the circumference was 70, divided by pi. So D is equal to 70 divided by pi. And that gives me 22.3 to 1 decimal place. Now, luckily for you, the units are all in centimeters. So that would be, question 1 would be 6.3 centimeters. Question 4 would be 60.9 centimeters, a lot bigger. And D is the biggest one because it has a circumference of 70 and a diameter of 22.3. So please use your formulas that I've given you. I've given you 3 rules. C equals pi d, or C equals pi times 2r. And if you want to find the diameter, you need to use d equals c over pi. Now, I've just realized that this one asks for the radius and this one asks for the diameter. So I'm not going to do the last one for you, but I will give you the formula for that one. So number 6, the formula to help you is r. So I'm going to rearrange this one here. So I'm going to take the 2r and it's going to become c, like the last one, only instead of it being just pi, it's going to be 2 pi on the bottom. And you have to put that in brackets just to make sure it's all together. So c divided by 2 pi. You can either use the fraction button on your calculator, or you can just press C, the divide button, by 2 pi. And then to be safe, put brackets round it in case you do a little typo. So it's all based on the same formulas, but just some rearranging for R and D. I look forward to seeing how you get on. Right, on to question 2 is always the problem solving real life one. So it says Billy likes to go cycling. His bike has wheels of diameter 85 centimeters. So that's telling me that here the diameter is 85 centimeters. Now, based on all the ones above, that is actually the biggest. I don't think we have a diameter 85, so that's, think about an adult bike. The wheel's going to be very big, isn't it? 85 centimeters is almost a meter. So those are big wheels. So it says he has invented a counter. A counter is something that's going to count something for his bike, which counts the number of revolutions. So some of you might not know what revolution is. A revolution means a full turn. So if you've got a bike and your wheel makes one full turn, that is 1 revolution. Alright? So if you think of the little trundle wheels that you used as well before, it clicks every single time the wheel goes round once. If you remember something like this, it was a trundle wheel. It goes down, it's got a little clicker and a wheel, and you pushed it, you held it, and then when the wheel, it had a little clicker, when the wheel went round once, it would click. Then it would go round again, and it would click. So that's what it means when it's talking about a revolution. The wheel goes round and round and round, and he's going to count how many times. So one day the counter shows 180 revolutions. So he was out cycling his bike, and the wheel went round and 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 round 180 times. Okay, 180 revolutions. How far has Billy cycled? Give your answer to the nearest meter. So, you might be getting very confused right now. There's lots of words, a lot of revolutions, counters. It's telling you the diameter. It's telling you how many revolutions. So how do we go about this? Well, it's a circumference task. He gives us the diameter. So I'm going to find the circumference, because in order to find the distance travelled, I need to know the circumference of the wheel. So you might start to think about what's going on now. If you know the distance around the wheel, if you know that distance and you know the wheel's travelled 180 revolutions, you might be able to figure out what is the distance he's travelled. So C equals pi times, and the diameter was 85. C equals pi d. So now I'm going to put that in. Pi times 85, and it's going to give me quite a big number. 266.9, and that is in centimetres. Now it says we want the answer in meters, so what you're going to do here is you're going to change centimetres to meters. So if you think back to unit 1, when we changed or it was unit 2, changing centimetres to meters, we have to divide by 100. So I'm going to do 266.9 divided by 100. Now you don't even need a calculator for that, you just need to remember that the decimal moves 2 times to the left. Mr. DL. So now that is in meters. But I'm not finished yet. That is just one revolution. That's if his wheel goes 1 time round. So if his wheel, he goes out on his bike, he's out on his bike and his wheel goes round once, he would only travel 2.669 meters. But we don't want it for just once. We want to know that his wheel went round and round and round and round and round. Can you remember how many times? 180. So I've got to take my circumference, which is 2.669, and the revolutions, which equal 180, and can you guess what I'm going to do with them? Take a moment to think before I give you the answer. Am I going to add them? Am I going to subtract them? Am I going to divide them? Or am I going to multiply? He goes round and round and round 180 times. 180 times. Think about that keyword I'm just saying. So yes, you've got it. The total distance is equal to the circumference multiplied times by 180. And that gives me 480.4 to 1 decimal place, but it asks it to the nearest meter, so that's going to be 480 meters. Nearest meter. Okay, boys and girls, I hope I have been a great help here. You have to do this on your own now. I hope you watch my video more than once and you're taking good notes. Remember to write down your working, take a photo of it and upload it into your class notebook in the Mymaths section. If you don't do well in the first task, the first attempt, what should you do? You should message me, take a photo of your working and ask me, what did I do wrong, sir? Or watch the video again and redo the task again. Good luck.